Now that we have talked about ionic bonding and metallic bonding, we can talk about the third type of bonding, which is covalent bonding. Ionic bonding, remember, was a transfer of electrons, while covalent bonding is a sharing of electrons. Covalent bonding involves a nonmetal sharing its electrons with another nonmetal. In covalent bonding, both atoms' nuclei are attracted to the shared electrons. Examples of things that exhibit covalent bonding would be chlorine bonded with chlorine and hydrogen bonded with oxygen. Now, I kind of show this picture because it shows the little kids not sharing very well. Covalent bonding is the strongest form of bonding simply because the atoms have to be so close together. Because they share, they have to stay in very close contact with each other, and it's almost like the atoms are holding hands. That's how close they have to be to each other. The electrons are shared in a way so that each atom in the bond will obey the octet rule. So let's take a look here. I know you have room for a couple of examples here. So let's again go through the Bohr structure, and then I'm going to show you how we can do this using Lewis dot structures here in a minute. Okay. So the first one looks like this. This is the combination of hydrogen with fluorine. And as you can see, their rings actually literally overlap with each other. So let me pop this up here. Okay. These electrons here are the ones that they share with each other. Actually, let me make that a little bit brighter. Okay. These are the shared electrons. So they actually count for both atoms. All right. So if you look at this here, let me erase that. On my fluorine, I have 1, 2, 3, 4, 5, 6, 7. One of those shared pairs came, or shared electrons came from fluorine. And then hydrogen, which has 1, shares its 1 with fluorine to make 8. Hydrogen needs 2 electrons, remember, to be stable, and that's exactly how many are in those shared electrons. Now we can also have this in something more complex like carbon dioxide. Okay, you can see in the circled areas there we have the shared electrons, and they count for both atoms. So if I am looking here for my carbon, okay, look at your outer ring. You've got 1, 2, 3, 4, 5, 6, 7, 8. So carbon is therefore stable. For this oxygen, I have 1, 2, 3, 4 that are not in the shared, but then I count all of these, 5, 6, 7, 8, so that oxygen is stable. I go over to the other oxygen, 1, 2, 3, 4, and then in the shared, 5, 6, 7, 8 makes it stable. So sharing in this way actually allows carbon and oxygen to be stable. If you just want to write H with F, okay, and CO2, those could be your examples of covalent bonds. Now, based on what we've learned in terms of covalent bonding, I want you to take this little quiz. I want you to pause the video and circle which combinations of elements form a covalent bond. Okay, now that you've had some time to kind of reflect on that, our covalent bonds would be the hydrogen with the hydrogen, letter C, the oxygen with the fluorine, the sulfur with the chlorine, the nitrogen with the hydrogen, and the iodine with the nitrogen. All of those are nonmetal to nonmetal. Now the one I tend to get questions about is this one, letter G. Everybody looks and they're like, nonmetal, nonmetal, nonmetal. So why is this not covalent? It's because of this and this. Each of those have a charge, and so that shows that they are ionic. This is a metal and a nonmetal. That is a nonmetal and a metal. Oh, and I forgot, we also have one more. I'm sorry, I forgot. Letter I is also on our list. I thought I was done, and I wasn't. Okay, because that is nonmetal with nonmetal. Sorry about that. When we have covalent bonds, we form a molecule. A molecule is defined as two or more atoms that are bonded together covalently. Molecules can actually exist on their own. So in other words, I could actually pick up a single molecule of something. I can't really pick up a single ion of something. A molecule is represented by a molecular formula. This represents the actual number of atoms that make up the molecule. In an ionic compound, we use the simplest ratio. Okay, but in covalent bonding, we don't write it always as that way. Now, there's a couple of specific types of molecules I want to talk with you about. There are the diatomic molecules. This is a molecule made up of only two atoms. And in this one, the molecules do not have to be different from each other. So examples of things that form diatomics, or that are diatomics, are H2, that is diatomic, O2, that is also diatomic, HCl, two atoms, those are different, and CO, which is also different, and that is also diatomic. Many elements actually exist this way, and we actually have a mnemonic to help us remember that, and that is Brinkelhoff. Okay, it stands for bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So that's the mnemonic that we use to remember the diatomics on the periodic table. We also have monatomic molecules. So these are one atom molecules because they can exist independently without having to form a bond. And the only examples we have are the noble gases. And these are actually, we would call them neon lights, but that's actually not true. Each of these gas tubes are filled with the different element that is, or the different noble gas that is listed there. So you can see how the different noble gases can be used in so-called neon lights to produce different colors. Neon actually only exists in that red-orange color. Now, before we talk about how we write covalent bonding in Lewis dot, let's go through some of the properties of molecular compounds. Molecular compounds tend to be soft. They also tend to be poor conductors, but they are excellent insulators. They have low melting and boiling points, and they can exist as solids, liquids, and gases at room temperature. Examples of molecular compounds include things like wool, carbon dioxide, water, and wax. Now, let's take a look at how we form covalent bonds using Lewis dot diagrams. Okay, so let me pull up here so I can write. Awesome. Okay, so we're going to start, we have to pick two non-metals. All right, and in this case, I am going to pick carbon, which is a non-metal and has 4 valence electrons. And I'm also going to pick oxygen, which has 6. Okay. Now, these electrons are shared, so we can't draw an arrow to show this. What we actually do is draw a circle. Okay. So these 2 electrons are getting shared between the carbon atom and the oxygen atom, and so they will count for both. So if you look at this one, I've got one on oxygen, I have 1, 2, 3, 4, 5, 6, I now have 7. In addition, I also have this other, or this second unpaired electron. So that also can get shared with the carbon to make 8. Now if I count for the carbon, I have 1, 2, 3, 4, 5, 6. So it is only at 6, so I need to add another oxygen to share. So this will share this way, and this will share this way. Now, unlike our ionic compounds, we don't have to redraw these. We actually leave them just like this to show that they are sharing. Now that one is probably a little complex, so let's try another one that's maybe a little bit more simple. Okay, let's do one between, let's do hydrogen and sulfur. Okay, hydrogen wants to be stable with a number of electrons of 2. So it will share its one electron with one of sulfur's ones that does not have a partner. Hydrogen is now happy because it has 2. Sulfur now has 7. So you can also draw a second hydrogen and draw that in there. That's another example of sharing with a covalent bond. So based on this, you should be able to go ahead and do the practice worksheet that's on the back of the one where we did our ionic practice the other day, and go ahead and go through those 6 problems, and we will review them.